All right, everybody, what we're going to do is we're going to look at center of mass. I have some people who are just a little confused in a good way because you're like, the AP classroom one, it wasn't working for me. I got you. So here's the big idea. If I have two objects, two things of mass, that there is a point in between them where there is a center of mass, that I could balance it. Way to think about it is it's a spot where the torques would be, cancel out. We're going to talk about torque next week, but the idea of both of these are going to try to twist if you had them connected, but there's that sweet spot where if I could balance it. So we refer to that as the X of your center of mass, your position. Well, to have a position, you have to have a zero, okay? So the key to these is you set a 0 point and you just measure everything off of that 0 point, okay? So as we look at the equations in a second, that's the key. Where that 0 point is does not matter, okay? If I deal with stuff that's on a beam or in a line, I just set, my experience, always set your X to the left. Make your life easy, okay? Two dimension, we're going to do in a second. We'll show you how to do that. So let's scroll down on this. So one of the things it has here says for a system of masses, this is your setup. I want you to see what this means. What this means is, let me click on this guy. This guy's a little better. The big M, total mass times X of the center of mass. So in other words, where the center of mass is times the total mass, that's going to equal M1. M1 is like the little object, and X1 is the location of that object. M2 is the little object. X2 is the location of that little object. So you add those two up, that would give you what the total mass and the location of the center of mass, okay? So if they're equal, it'll be halfway in between. If they're unequal, it'll be more toward the big one, okay? So now, this is what it looks like. So this is the tough part is if you start working with it, it gets crazy quick. You're like, oh my gosh, what's going on? Okay, so we're gonna do a couple of these right now. This is a two-dimensional one. We'll come back to this. Actually, yeah, we're gonna do a couple problems. Where's a problem? No, I want a problem. There it is. Like here is a good one. So a metallic sphere of mass 1 kilogram. Or it has the answers written on it for it. So hopefully we get it right. Metallic sphere of mass 1 kilogram and radius of 5 centimeters. The radius is 5 centimeters. Is welded to the end of a thin rod that is 50 centimeters long and has a mass of 0.5. So this guy is 1 kilogram. This is a mass of 0.5 kilograms. Okay, so there's just our information. That's all we're doing. We're just getting started. Okay, step one, set a 0 point. I'm going to refer to this as X equals 0. Why? Because I can. Okay, so first thing we're going to do is we're going to draw out where are the center of masses of these objects. So this rod, it'll be in the middle. Okay, this sphere, it'll be in the middle. Okay, so I'm going to call the rod X1. So it's going to be object 1. I'm going to call the sphere X2, okay? And this is going to be mass 2. Mass 2 is going to be 1 kilogram. Mass 1 is going to be 0.5 kilograms. So what we do is we say the total mass times the position of the center of mass equals the mass 1 times its position of its center of mass, mass 2, its center of mass, okay? So the total mass is going to be 0.5 plus 1. I don't know where its center of mass is, so I'm just going to put an X there, okay? The first mass is 0.5. The second mass is 1. Where is the location of its center of mass? Its center of mass is right here. Well, if its total length is 50 centimeters, its center of mass is at 25 centimeters away from this red line I drew, okay? Now, X2, we're going to look away how far away it is. So the length of the rod is 0.5 plus the radius is 5 centimeters. So how far away is that one? Well, it's 50 plus the radius, 55 centimeters. Okay. So X of the center of mass is going to be 0.5 times 25 plus 1 times 55. These are centimeters all over 1.5. Solve that out. And I get the X of the center of mass. What that number means is where you would balance it to get it to not fall. So that's like, it says 45. In other words, if you put your finger right there, you could balance this thing. Think like a golf club or something. That's a spot where you could put it. I'm going to scroll down a little bit. So if I have these guys, okay, 3-point masses are connected to a massless rigid rod. I wanted to use something that was modeling some AP questions. So mass 1 is 2, it's at 1 meter. Mass 2 is 1, it's at 2 meters. And mass 3 is 0.5 at 2.5 meters. Okay. First thing, this one they gave you, this is 0. Okay. They said 0 is over here. So total mass is 1 plus 2 plus a half, so 2.5. Okay. X of the center of mass. Let's get my face out of there. So the first guy is 2 kilograms. He's 1 away. Next guy is 1 kilogram. He's 2 away. And the next guy is half a kilogram, and he's 2.5 away. Solve that out, and I'll get where the center of mass is. And what's cool is it'll actually match something that's conceptual. Like if I stick it right there, kind of in that spot towards the heavy one, kind of in there, that's the right answer. Okay. I want to get to one where it's 2-dimensional. Coming up. Yeah, those ones are good practice ones, but I want to do a 2-dimensional one. So this would be a good example of a 2-dimensional one. Find the center of mass of a uniform sheet of plywood in the diagram. What? Okay. Step 1, uniform, meaning the mass density is the same. So this is where it gets a little tricky. So we're going to say the center mass of that guy's there, center mass of this guy's here. Okay. So if I look at each of the pieces of plywood on their own, okay. Job 1, I'm going to call this the 0. I'm going to call this the 0. Okay, that's first job you're going to do there. Next up, we need to find out what their mass is. Okay, so that's where it's going to get tricky. This is where these problems can get a little weird. You're like, what? Okay, so I'm going to call this sheet of plywood, this little guy, just M. Okay, kind of cheating, right? So M1 is going to be, well, if I look, I got 0.2 times 0.2, so its area is 0.04 meters squared. Okay, let's look at the big guy here. This one is 0.8 times 0.4, which is 0.32 meters squared. Look at how many times bigger it is. So if the top one is 0.04, the bottom one is 8 times bigger. So if that's M, this is 8M. Notice what we're doing. We're just kind of going through and going, oh, okay. So that's mass 1. Mass 2 is equal to 8M. Okay. Now, we're going to do a couple things to help us out here. The X location is 0.4 away for the center of mass, because that's in the middle. The whole length is 0.8, so 0.4 is halfway. This guy's center of mass is 0.1 from the edge, which is 0.6 from here. So its center of mass, this total distance, is 0.7 meters. So what we do is we look in the X direction. Okay, total mass times X of the center of mass equals mass 1 x1 plus mass 2 x2. Okay, hand cramp. Okay, total mass is going to be 8M plus 1M, X of the center of mass. Mass 1, big guy, mass 1 is the little guy, Mass 1 is the little guy up there. We're just going to say it's M. Its location of its center of mass is 0.7 away from my 0. The other guy is 8M. How far away is he? 0.4. Okay. Solve that out. I've now solved for the X location of the center of mass. So if I solve this out, I get 0.7M plus 3.2M all divided by 9M. So I get 3.9 over 9 is my meters, is my X of my center of mass. Now the question is, Schmierer, what do I do to find the Y? Are you ready? Now you do the Y. So now when you do the Y direction, same exact process. How far away is it from my 0? I'm going to call this my 0. Well, if it's 0.4 total vertical, it's going to be 0.2. So it's 8M is 0.2 away. The next guy, well, where is he? He's here. He's this distance vertically. So that's 0.4 plus 0.1. So that M is 0.5 away. So the total mass which is 9m times x. So I have the total mass times the position of the center of mass. That's a y. Let's be consistent. So 9 masses times y equals that. So, so you now have your y location. So it's 3.2. 3.2 plus 0.5 is 3.7 over 9 meters. So your y is there. Your x is here. So you now have your x and your y position in that's your location. Now, the calculus portion of this is how to tackle what if it's not uniform density. And so that is where you would apply. So the idea is the total of the masses, the integral of dm, equals the integral of x dm. In other words, the positions of the masses. And so if they gave you a density equation of density equals mass over length, what you would do is you would say, okay, well, knowing that, I can say my mass, right? I could define my mass in terms of density times where I'm at. And so that's where this guy comes from. Call this your linear mass density. We will practice this more when we do circuits, because we can look at charge density over an area. So we're going to devote a week together to that too. So, okay. I wanted to do one more. Ready? So let's do this. Let's give us some closure here. Is two masses of 50 and 200 are placed at the end of a seesaw. So here's my seesaw. Okay, 50 and 200. The question is, where would you put a pivot point? Well, if I put a pivot point over here, it'd bounce. The pivot has to be at the center of mass. Okay, so what do? Call this side x equals 0. Mass times x of the center mass equals mass 1, x1, plus mass 2, x2. Okay. Total mass is 50 plus 200. Okay. First mass is 50. Where is he? He's at 0. Get out of there, Schmierer. The other guy's mass is 200. Where is he? I don't know. X away, which is L. Okay. So x of the center of mass is 0 plus 200L divided by 250. So I get, at the end, the answer's on the screen. Okay, but that is a strategy to do this, is find out where the center of mass is, put it there. Now, what if they said, oh, the board has a weight too? Well, the board has a mass. Where's its center of mass? It's at L over 2. Notice how you have a 0 there. You can use that 0 point to measure from. So again, I know AP Daily had some videos for you, but I had a lot of questions going, this isn't working. So hopefully this made it a little bit better. So thanks for tuning in. Keep it real. Check it out. Get a new microphone. All right. Talk to you later, guys.